Hello, Matthews Gatos here. Let's look at page 325, number 6. Okay, so we have a rectangle where it has vertices AD on the equal sides of an isosceles triangle and BC on the base. Let's draw a picture to see what this looks like. So I'm going to start with my isosceles triangle first, and then I'm going to draw my triangle connected to the equal sides and the base like that. Okay. Let's label our vertices. So A and D are on the equal sides of the isosceles triangle, and B and C are on the base. Now I know that AB is 2, and I know that BC is 6. I want to find the value of the base angle, that would be this, that represents or produces a triangle with a minimum area. Okay, so in terms of my triangle, I'm going to have to find out area of a triangle, I'm going to do base multiplied by height, which is from the vertex to the base. Base times height divided by 2. Now, I have to write that in terms of theta because I need a trig derivative and I want the angle that produces a minimum area. So let's look at the base first. So I know for the base I have 6, and then I have these 2 little bases on either side. Those triangles will be equal on both sides. So my base is going to be, I'll call this a little b. Little base plus 6 plus another little base, which is really just 2 little bases plus 6. That will be my base. So let's start with the base first. So I'm going to look at this triangle right here using that angle. And I'm going to find an expression for little base using the angle N2. So opposite over adjacent, that would be tangent. So let's write that out. So tan of theta is opposite over adjacent, which is b. Multiply both sides by b to get rid of that fraction, and then divide both sides by tan. So 2 over tan theta is equal to that little base. Now 2 over tan, the reciprocal of tan is cotan, so I think it'd be easier to write that as cotan theta. Okay, so the base of my big triangle is 2 of those little bases, so 2 cotans, which would be 4 cotans, plus 6. So that's what the base of my big triangle is. Okay, now let's look at the height. So to find the height, well, let's draw down the height on the inside from the apex down to the base. Because it's an isosceles triangle, it splits that base into 2 equal pieces. So I am going to actually focus on this triangle right here. So the reason I'm going to focus on that triangle is because I know that my height is made up of this length right here, which I know is 2. Plus this, whatever this little height is, that height of the yellow triangle, that will be the height of the big triangle. Now I know that the yellow and the green triangle are similar triangles because they have the same angle, like it runs in the same direction. These are both 90-degree angles, so I know that they are similar. Now because that height of an isosceles triangle bisects the base, this whole thing across here was 6, but since it cut it into half, this little piece here is just 3. So using opposite and adjacent, I have tangent again. So over here, I'll write down that tan of theta in the yellow triangle is opposite over adjacent. Multiply both sides by 3 to get rid of the fraction, and I get that the height is 3 plus tan theta. So over here, 2 plus the height, which is 3 tan theta. That will be the height. Okay, so now that we've got height and base in terms of theta, area of the big triangle is base, 4 cotan theta plus 6, multiplied by height. Let me just move this over. So I'm going to multiply that by height, which is 2 plus 3 tan theta, divided by 2. So I want to find the theta that will give me the minimum smallest area. So let's take this to the next page and let's simplify it a little bit before I take my first derivative. Okay, applying the distributive property, 4 cotan times 2, 8 cotan. 4 cotan times 3, tan would be 12 cotan tan. Now, multiplying cotan and tan, hopefully you see that that cancels because cotan is the reciprocal of tan. So if you multiply anything by its reciprocal, that's just 1. Plus 6 times 2 is 12. Plus 6 times 3 tan theta is 18 tan theta. And that will all be divided by 2. Okay, so area 8 divided by 2 is 4 cotan theta. Plus 12 divided by 2 is 6. Plus 18 divided by 2 is 9 tan theta. Okay, so that will be my area. So what I want to do is take the derivative of that. So to help me with my trig derivatives, I'm just going to write this out on the side to help me out. Remember the secret that I told you to remembering them was pst. P stands for positive, and then it's secant tan, and then I'm just going to flip all that, so negative, so secant is cosecant, flip it around, cosecant, and then cotan. This is going to help me with my derivatives. Well, it helps me anyway. I hope it helps you. So my first derivative is 4 times the derivative of cotan is cosecant times cosecant, which is negative cosecant squared. Plus derivative of 6 is 0, plus 9 times the derivative of tan. Derivative of tan is secant, and it's positive, secant squared. Okay, so that is going to be, I'm going to write the 9 secant squared first because it's positive, minus 4 cosecant squared. Okay, so I want to set the first derivative equal to 0 so that I can find the critical values. So setting it to 0, and then I'm going to factor because I notice that this is a difference of squares. So square root of my first term would be 3 secant theta. Square root of my last term would be 2 cosecant theta. Oops, cosecant theta. That's really messy. Let me try that again. Okay, so 2 cosecant theta. There we go. Add one set, subtract the other. Okay, I want to set each of these to 0 and find out what my critical value is. This is a very involved question. Okay. So let's see what I want to do. Okay, secant is the same as 1 over cosine. Cosecant is the same as 1 over sine, equal to 0. Okay, I don't think this is a simple unit circle question. So I'm going to choose to get rid of one of my denominators. Doesn't matter which one. I'm going to say multiply everything by cos. Multiply everything by cos. Okay, so that's gone. So I'm left with 3 plus 2 cos over sine equals 0. Okay, now I'm going to subtract 3 from both sides. So I have 2. Well, wait a minute. What's cos over sine? That's just cotan. Cos over sine is cotan. So 2 cotan equals -3. So cotan equals, divide both sides by 2, -3 over 2. Okay, I'm going to do that in terms of tangent. So if cotan is -3 over 2, I know tangent, flip, is -2 over 3. Okay, now just looking at the cast rule, tangent is negative in quadrant 2 and quadrant 4. So I'm definitely looking at a quadrant 2 potential angle. Now that isn't a nice angle in the unit circle. So I'm going to go to my calculator. I'm going to go tan inverse of 2 over 3. Okay, so 0.588 we'll call it. Okay, so theta is approximately 0.588 radians. Okay, let's go to the other one, see the other critical value. So oh, there it is. I'm like, where am I going? Okay, let's go to this one here. So 3 secant. Secant is 1 over cos minus 2 cosecant. Cosecant is 1 over sine equal to 0. So again, you can just multiply by whatever you want. So I multiplied by cos last time. Let's change it up, spice up our life, and multiply everything by sine and see what happens there. Okay, so 3 sine theta over cos theta minus the sine thetas are gone, 2 equals 0 times anything is 0. Now, sine over cosine is tangent. So this is 3 tan theta minus 2 equals 0. So 3 tan theta equals 2. Divide both sides by 3, and tan theta is equal to 2 over 3. Okay, so let's do that one on our calculator. Oh, that's that one. Okay, sorry, I made a boo-boo. So this one is approximately 0.588. Let's go back here. You guys have probably already caught my mistake. Tan inverse of negative. Let's try that again. Okay, so tan inverse of, let's do that again, but I'm going to back up the bus and insert a negative in here. Okay, so insert a negative. I'm going to get a negative angle. So to put that into quadrant number 2, I'm going to do pi minus my reference angle, which is my -1 over here. Okay, so that will be too much to be in a triangle, because I know that whatever angle I have, it has to be less than pi over 2. And pi over 2 is about 1.57. So this is definitely not in there. So we're going to go back over here. And we're going to say that in the triangle, this angle is not possible. So there is no solution in this one. So it looks like my critical value is going to be about 0.588. But don't hate me. We have to verify that that actually gives a minimum. Okay, so we're going to go all the way back up here, take our first derivative. I'm going to go to a new page. There we are. And let's do our second derivative. So remember, second derivative test, we have to figure out, does this actually produce a minimum? Okay, so I'm going to need my, again, so positive, and then I'm going to go secant tan, and then flip all those. So this becomes cosecant, and cotan. Okay. So the derivative of 9 secant squared. Actually, I'm just going to write this a little bit differently before I go ahead and do that. So I'm going to write this as 9 secant theta squared minus 4 cosecant theta squared. Okay, now let's do our second derivative. So 2 comes down. 2 times 9 is 18 secant theta. Now, the derivative of secant theta is secant tan. Remember, summertime derivative, you sec a tan. Okay. Minus, bring the 2 down. 2 times the 4 is 8 cosecant theta. And then the derivative of cosecant is cosecant cotan, but it's negative. Negative cosecant theta cotan theta. Okay, I'm just kind of squishing it in there. Okay, so second derivative is 18 secant squared theta tan theta. 2 negatives make a positive, plus 8 cosecant squared theta cotan theta. Okay, so what we need to do is check when theta is approximately 0.588, I believe, is the second derivative positive or is it negative? And I already know what you guys are saying as I'm going through this question. Is there going to be something like this on the test? I think this might be a little bit advanced for the test, but not for university calculus, which is what I'm preparing you for. So let's go ahead and try this one. Okay, so let me just think. So 18 secant squared. Okay, so 18 times, I'm going to go 1 divided by, secant is the reciprocal of cosine. So I'm going to do cosine of 0.588. And then I'm going to square that. That's 18 secant squared. And then I'm going to times it by tan of 0.588. Again, I'm just doing this to find out, is my first derivative positive or negative? Second derivative, sorry, for the critical values. And then 8 times cosecant. Cosecant is the reciprocal of sine. So 1 divided by sine, 0.588 bracket squared, times by the cotan. Cotan is just 1 divided by tan of 0.588 bracket and bracket. Okay, I want a minimum value, so I want this to be positive and open up. If it's negative, I'm going to cry. It's positive. Thank goodness. Okay, so it's positive, which means I'm concave up, which means I have a minimum, which means that this is a critical value that produces a minimum. Yahoo! Okay, 0.588. So let's go back all the way over here. And the base angle, which is theta. So theta equaling to approximately 0.588 radians will produce a triangle with a minimum area. I need to drop the mic after this question. That was a really tough question. So I hope you guys were able to follow that through, but no, I am not going to ask you guys something to this level on the test. Phew! Okay, hope this helped. See you for the next one.